Welcome to today's event. I'm Gemma Monk-Hartley from Herefordshire Green Network's Building Sense Group, an initiative that was started in 2020 to bring together people, information and professional expertise to help with the challenge of making homes comfortable year-round in the face of high heating bills and, of course, cutting carbon emissions. Since 2022, we've been partnering with local charity, March's Energy Agency, on Future Ready Homes, a programme that promotes and supports good practice retrofit of homes across the Marches area, that is Shropshire, Telford and Wrekin and Herefordshire. It's doing this through a webinar series, and this is one of many, retrofit advice, events like Green Open Home and the Future Ready Homes Directory. So that is it. It is now over to our speaker. Today we have local architect and energy efficiency expert, James Smith, who is going to tell us all about windows and doors with a view to improving the energy efficiency of our homes. Right, so I shall stop sharing, James, and hand over to you, please. Yeah, that's it. And you need to take yourself off mute as well, James.
There we go. Can you hear me?
Yeah, loud
Jolly
and clear.
good. Good afternoon, everybody. I'm James. I hope you can all hear me okay. Apologise if I'm a little muffled. My darling 2-year-old son brought us a lurgy home from nursery over a month ago, and I'm still suffering from the consequences. It just will not go away. So I'm going to talk about fenestration. Windows really is what I'll refer to largely, but that basically includes doors, roof lights, anything else that's an opening from inside to out, basically. A little bit about me. I'm not a glazing expert as such. I don't have no affiliation with any glazing firm or install glazing. I've got a degree in architecture from way back when. I worked at as a project manager engineer for 5 years, actually latterly for a company who specialised in architectural steel and glass in largely airports and tube stations. So there's a certain amount of glazing involved in that, but that was mostly bomb-proof as opposed to energy efficient. And then in 2004, I gained a Master's in Architecture, Advanced Environmental Studies from CAT, Centre for Alternative Technology. Formed my company J3 with 2 friends, Julie and Jason. And we looked predominantly at domestic retrofit projects and always have done. Then in 2010, I did a professional diploma in architecture at AES. And then more recently, I've completed the level 5 diploma retrofit coordinator from Retrofit Academy. So these photos at the bottom, the bottom left is on Walter's Way in London, which is Walter Seagull House. Some of you might be aware of his designs, and I wrapped a Walter Seagull house up in a Walter Seagull house, basically. And so doubled all the insulation, and I think, yeah, triple glazing, I think. That was way back a while ago. And the next one is in Shrewsbury. That's a grade 2 listed place on town walls in Shrewsbury. All sorts of issues with the windows there. Eventually, the conservation officer allowed us to replace the top 2. He wouldn't allow us to replace the big centre one or the one on the ground floor. I can come on to that later on. And then the last 2, the building in which I'm currently sat, the English Bridge Workshops. I'm sure some of you know it. We're in dire need of new windows. The front and the sides are all glazed units straight into stone, and the rear, what's left of them, are timber framed. They're all busy falling out. So once we've got some money, we should be replacing all the windows in this building. It's a big subject, as you might be aware. So it's going to be a bit of a whiz through, but essentially we're going to look at the reasons for doing it, how to do it, and the various considerations for repairing or improving your fenestration, your windows. 16 slides after this one. So reasons to improve, repair or replace. Dilapidation, obviously, like here, if they're falling out and they're in a right old state, then you're going to want new ones. Energy loss, which is what this is all about in a way. Something between 10 and 20% of your total energy is probably going out of your windows, and therefore 10 and 20% of your costs. Comfort and health. Not only are you ensuring that you're losing energy, but you're actually warming up the window surface, which means you're less likely to have drafts, you're less likely to feel uncomfortable next to a window, even if your room's warm. And aesthetics. Where's my, oh, there you go. Yeah, no offense to anybody who's living in a 1930s semi that has a neo-Georgian front door and sort of medieval looking windows, but I think it'd be perfectly understandable if you wish to replace those for something more in keeping. Benefits, as well as the savings thermally and in terms of money, obviously an improvement in thermal comfort, so you're going to feel more comfortable in your home. Nothing says thermal comfort more than a sleeping cat. Reduced condensation. This picture, I think, on the top right is actually probably a blown unit as opposed to condensation on the glass bit. But either way, your window's going to look better if you can see out of it. Peace and quiet, better security. The bottom right, that's Ted, isn't it? I think he used to advertise glazing for Everest, and if I remember rightly, the feather was to prove that there was no drafts. There was also one about how quiet your windows were, and there's another one about there's a wrecking ball used to bounce off the window, which I presume had something to do with better security. So I call it the kitchen paradox. A lot of people, when they think about energy efficiency measures, expect a payback, or they think of it in terms of a payback. So you're going to make this investment, and I want to know that it's going to pay back in, I don't know, 10 years. But actually, you really should be considering all the other things that come along with that improvement, and basically just having a much nicer experience in your house, I think, is a reasonable benefit. Ways to improve, and the cheapest, easiest is heavy curtains. Obviously, that's not so good during the daytime, and you probably still will get a certain amount of condensation building up on the glass. This is assuming it's secondary glazing behind you. Single glazing behind your curtains. Window film, which is basically just like a cling film that you use a hairdryer to stick to the windows. That will definitely seal up gaps and improve the window in that respect. But it'll warm the surface of the glazing very slightly, but not to a great degree. And we have secondary glazing. There's two types there. There's the sort of magnetic strip and acrylic sheet secondary glazing on the left in the middle, and then more permanent secondary glazing. I had the acrylic sheet and magnetic strip stuff at my old house, and it was great actually, and immediately you tell the difference. And acrylic is a very warm material, so actually that helps in itself. Inexpensive, more expensive since COVID, but it's still relatively inexpensive, and very easy to do yourself. Permanent secondary glazing, you probably want somebody else to come in. I find some permanent secondary glazing systems to be quite ugly or a bit over the top, a bit large framed, but you can get nice slender ones. Apart from that, you can refurbish your existing glazing. If it's timber, generally speaking, and of a decent quality and a decent size. Replace the glass units, again, that's going to need a decent size of window baft in order to fit a double glazed panel into. Certainly something you can do with sash windows, probably less likely to do it with casement windows and other types of window, simply because it's possibly not worth it and you're as well to replace the whole thing. You won't probably be doing it with UPVC, because the odds are that the window, they're probably already double glazed, and the odds are the glass unit will need replacing at about the same sort of time that you'd want to get a new frame anyway. And then there's the new double glazing, the new triple glazing, of course, which we'll look into in a bit. Types of windows. I'm sure you're all aware of all these various types of windows. Casements, sashes, tilt and turns, a more modern type of window. The large advantage of those is that you can clean them from the inside as much as anything else. And they're often very good thermally. Bays and bows. I think a bay is if it's essentially a box, so it's got three sides sticking out of the room, whereas a bow is faceted, so it might have 4 or more sides. Fixed glazing, so you can't open any of it, was generally more efficient because there's no joins between the openable part and the rest of the frame, lanterns, roof lights, doors. The point of this slide really is to suggest that you don't need to stick with what you've got. You can swap between one and another. If you've got sash windows, you might like to change them into casement windows. Casements, generally speaking, are more efficient. Not always, but generally speaking. You're unlikely to be able to change a casement into a sash because of the amount of space you need for the weights either side. You might have a window that you never open, and actually you might as well make it a fixed glass window and save yourself a bit of energy in that respect. You might want to introduce a bow or a bay window into your lounge. They're letting more light, but obviously you're also introducing more glass surface, and so therefore probably greater losses all in. Oh,
I'm not, yeah.
someone hasn't got, there we go. If you are in a listed building, then you probably will have to just replace whatever you've got with the same, if you're able to do that even. And on that note, Article 4 direction. Article 4 direction removes the right of permitted development, which is a planning regulation that gives local councils the power to restrict the permitted development rights for a specific area or property or range of works or activity. So it might be as simple as restricting the amount of car boot sales on a school playground or on a field or something, or it might be restricting the conversion of a property into multiple flats. It differs slightly to a conservation area. I think the Venn diagram is probably quite a large shared area. Conservation areas are very specifically a designated area with special protection for its historical character. So the conservation area may also have Article 4 directions applied upon it. Either one of the top two, you'd have to have a conversation with the historic buildings team or with the conservation officers as to what you can and can't do. Generally speaking, in a conservation area, they will want you to do the right thing at the front. So in Cherry Orchard in Shrewsbury, where I used to live, it's all Victorian, so they want to see sash windows, even if they just look like sash windows, but they're actually casement windows. But at the back, you can more or less do what you like to an extent, generally speaking. Listed buildings are a whole different thing, of course, and they're very dependent on your local conservation officer, as well as the listing, as to what you will or will not be able to do. Back to the property I did in Shrewsbury, we battled long and hard with the conservation officer. My client was very up for making the building as energy efficient as possible. Obviously, with very large single glazing at the front, that was quite difficult to do unless you were going to replace it. Ultimately, the conservation officer was concerned that the new windows would be 1 millimetre further back into the facade, if you like, than the rest of the crescent, and so he wouldn't allow us to replace the windows. However, oh, beg your pardon. That was him, and that was then, and that may well have changed. Often they won't allow you to replace a window unless it's dilapidated, unless it needs replacing. Otherwise, they'll ask you to repair it, or they'll ask you to put secondary glazing on. Conservation officers are, however, generally very open to discussion. They'll come and have a look. I find them much more easy to deal with actually than planners often. And there's lots of information out there. Historic England have got all sorts of advice and guides about what to do, what not to do. Energy efficiency. So building regulations now, all windows must comply with the following. That Part L, new windows must have a U value of 1.2 or less, and a WER, that's a, what does that stand for? Windows efficiency rate, I believe, of B or better. And replacement windows must have a U value of 1.4 or less, and the WER of B or better. So the U value, just to quickly cover that, all materials have a K value, so they have, or a lambda value, a measure of their thermal conductivity per millimeter of depth. So the U value is the sum of all the various little bits and bobs that go into making that thing over its whole depth. So U values of windows can be measured by the glass, the center pane, which is often historically what window manufacturers have promoted. It can be measured by the frame only, or it can be measured by the whole thing. The Windows regulations, it must be a U value of the whole thing, so that includes the frame and the glass. 2/3 of the energy lost through a window is through the glass, but there are also losses through the frame, conduction and convection and air leakage. And so all of that needs to be considered to give you the overall figure. The British Fenestration Rating Council devised the Windows energy rating as just a simple way of showing the same information, really. So you'll get these on, especially on windows that you buy off the shelf, if you like. So from medium to larger companies who have a product, you're less likely to find your local joiner guy who could well be a really very good window manufacturer or window producer having WEB tickets on the WER, ticket on the windows. I'm not entirely sure how one gets around that. There must be a way. I suspect you probably just have to get the building control officer involved, who will look at the design and construction of the window and decide, yeah, that's fine, go for it, basically. I think if your local joiner guy copied a well-known window or thereabouts, then it could show that it was going to work in terms of its energy efficiency. Other building standards, you don't really need to know these. You just need to know that they're there and that your Windows manufacturer installers know them. Ventilation is a big one now, of course. This is relatively recently added to the building regs, and we'll come on to that a bit later. The British standards generally is about the manufacture of windows. The glass. Quick glass history lesson. Even a listed building, the chances are the conservation officer will want you to mimic the glass that the rest of the building's got or had, and might not do. Back to Crescent Place in Shrewsbury, because of the windows were 200 years old, the squares were different. So you have some of the original glass was still in there, which was cylinder glass. There were bits and bobs that had been replaced over the time that were hand-drawn glass and machine-drawn glass and modern float glass. So actually, we went to great effort to mimic, rather than it all being cylinder or all being float, we're going to have different panes of different things so it actually matched the rest of the Crescent. But anyway, he didn't. That wasn't enough for him. Toughened glass. The regs for toughened glass is that. Where is it on there? The top there. No, not the top there. No, it's not on there. You need toughened glass for any glazing between ground and 800 millimeters, basically, so it can't get kicked in, essentially. And toughened glass to the side of doors as well. Low E glass is the most modern thing. It has a coating of metal oxide on internal glass surface, which reflects heat back into the room, but still lets in light from outside. So most visible light is emitted, and most UV light is emitted, and most of the warmth of the sun is emitted, but not all. So the pros are that it retains energy, much more energy efficient. However, it does block out more sun, which can lead to overheating from within. Sorry, the metal coating can lead to overheating from within, but also blocking out the sun means it's going to be a bit darker, so you might have to put your lights on more. You might not get as much warmth in from the sun in the winter, so your heating system then picks up that little bit. So it's not a straightforward calculation, and it's more expensive. I've also stuck on this slide some photos of shading. Basically, obviously you wouldn't know it necessarily today, but in the summertime, you want to try and stop as much sun getting into through your glazing as you can, probably, but not so in the winter. So all these shades are sort of designed to allow in the winter sun and keep out the summer sun. My favorite is greenery, growing trees or vines or whatever that block out the summer sun, allow in the winter sun, but they also, by nature, also provide a cooling effect through transpiration. So it's quite a neat solution, I think. Material considerations. Again, I don't suppose anyone's going to be surprised by these. Perhaps Accoya. So UPVC. The thing about UPVC is it's inexpensive, for sure. However, the manufacture isn't particularly ecological, and the disposal isn't ecological. PVC is made from vinyl chloride monomer, which is a class 1 human carcinogen, most of which happens in China. So it's one of those sort of externalizing things. We don't need to be bothered about it here because we don't have to put up with it here so much, but it's not the nicest stuff. And it also emits dioxins and hydrogen chloride when it's burnt. So it depends on then how it's disposed of. It is inexpensive, and I appreciate that. That's, often the biggest reason, or the only way perhaps, that people are able to replace their windows. Aluminium steel is very durable, low maintenance, high embodied energy. The windows that we'll put in here, probably at the front, straight into the stone, will have an aluminium or steel frame because it can be very low profile. Softwood, hardwood windows. Softwood shouldn't warp if it's been properly dried. Obviously, it's more liable to rot than hardwood. So both of which, softwood, hardwood, have a certain amount of maintenance that will need to be done through their life, but they're also likely to last possibly twice as long as UPVC or steel, or more. I mean, I lived in a Victorian building that still had its windows, so it was a 100-year-old window and going strong, really. Accoya is pickled wood, so Accoya is a softwood that has been essentially soaked in vinegar. That drives out all the moisture and makes it very lightweight, very hard, very good against rotting. Accoya, however, remains very expensive, purely, I think, because of probably not that many people are using it still, and there's a lot of plant that needs to be paid for. However, in time, I suspect it will come down and it will be the material of use. Maybe it'll even take on UPVC as a sort of cheaper material, if you like. And then composite, which is the little picture on the bottom left, is often a timber core with a metal outside, thus protecting the timber core. Often they're really high-end sort of Scandinavian, German windows are composite windows, and a lot of triple glazed windows, probably composite windows. They probably last longest without maintenance. Generally speaking, I would say you get what you pay for, as a pretty hard rule. So double or triple, I put together this little table. Let's move this out line. I apologise to people who may be looking at this on their phones. You probably won't be able to see all these little numbers. Essentially, I've started off with a window that's 2 meters squared. Single glazing, I've ascribed a U value of 4. Double glazing, 1.4. Triple glazing, 0.8. Given a certain amount of heat loss throughout a year, single glazing would be responsible for 355 kilowatt hours lost, £35.50. This double glazed window lose 125 kilowatt hours, £12.50, and the triple glazing would lose 70 kilowatt hours, £7 a year. So then I've assumed the double glazing would cost £1,000. Triple glazing is generally 20% more, so £1,200. The 2 windows would save so much. Over 25 years, they would save 5,750 kilowatt hours, 7,125 kilowatt hours respectively. Over 25 years, that equates to £575 for the double glazing, £712.50 for the triple glazing, which you spent £200 more on in the first place. So actually it comes out pretty similar. These prices are all based on current gas price, by the way, as is the, and I normally put CO2 on here as well, but I have just to fit it on better, really. So all in all, £1 per kilowatt hour saved, so £1 spent per kilowatt hour saved, they come out the same. However, triple glazing does offer the fact that the internal glass pane is much warmer than double glazing and certainly than single glazing. So the temperature difference in the last column, that's 20 degrees between, it must be at a particular day or a particular temperature outside, but potentially 20 degrees difference between the single glazing glass and the internal desired temperature. Whereas with double glazing, that's 8 degrees, and with triple glazing, it's only 4 degrees. 4 degrees or less, you won't notice in terms of thermal comfort and in terms of air movement and drafts within the house. 4 degrees or less won't change things, you won't notice it. So it's much more comfortable. So I would suggest that probably your extra 200 quid, or actually it comes down to like 70 quid or whatever, is worth spending for that extra thermal comfort. Other design considerations, optimum spacing between, this is between double glazing particularly, between the two glazed sheets is between 16 and 20 millimeters. Anything less than 16, and you're going to get more conduction through the glass. Anything more, and you potentially get convection currents within the void, and then you'll get more losses. So the ideal is between 16 and 20. You can get gas-filled units, which improve the window performance by reducing conductive and convective heat transfer through the glass. Often they're used with the low E coating. Adds cost, and also there's no really way of knowing whether the gas is still in the window. The long-term integrity of the fill could be an issue. Warm edge spaces, I assume these are the little strips that separate the two panes of glass. Often they were aluminium. I assume now with such exacting U value standards, they've probably all gone to a warm edge spacer, so they're just plastic or rubber rather than a metal, and then removes that cold bridge between the two glass panes. More tiny little numbers, I'm afraid. So again, I've based these on a 2 meters squared window of all these various types: single glazing, secondary glazing, UPVC frame, aluminium frame, softwood frame, hardwood or Accoya frame, and then a composite frame, to which I've ascribed U values, which then gives us a kilowatt hour loss over a year, and again a cost per year of that window. I've then added a capital costs, how much that window's cost you in the first place, with softwood, Accoya, and sorry, it's just the softwood and the hardwood, the Accoya, there's a maintenance cost, but with the secondary glazing and UPVC, sorry, with the UPVC and the aluminium, you're probably going to be replacing them every 25 years, whereas I'm assuming your softwood, hardwood, composite windows will last at least 50 years with maintenance. So in 50 years' time, the kilowatt hours total, and then therefore the pounds spent total, gives us a pound spent per kilowatt hour saved, again in that last column, which is the important thing. The secondary glazing is inexpensive up front, but actually costs quite a lot per kilowatt hour saved because it doesn't save as much as the other thing. UPVC is up there for sure. Aluminium's further down, possibly because it can't reach the same sort of U values, and I'm assuming it'll have to be replaced as much as the UPVC. The wooden timber windows are a good value, and then the best value is the composite window. So you get what you pay for, and also remember the new kitchen paradox. Very much consider how these are going to look, and also the quality of the experience, how much you enjoy looking at them, how much you enjoy using these things, these windows, and again with regard double, triple, the temperature of the glass and the sort of other considerations with regard to thermal comfort. It's not as simple as simply saying UPVC is the cheapest one. I'll get that. If that's all you can afford, then fair enough. That it's still going to save you a lot of money and improve your thermal comfort compared to your current leaky secondary glazing. But if you can, stretch yourself to whatever you can afford, because the more you spend, the better windows you're going to get, basically. Reinstallation considerations. So these little drawings are all looking at a window in plan. The top left, I'm assuming it's a brick and block house with a cavity, and it's as built single glazing, which may or may not result in a load of condensation gathering on the glass. If it's a very leaky window, it might not. If the house isn't warm heated very much, it might not. But let's assume that the as-built results in condensation on the glass. If you then replace that single glazing with double glazing, you may find that you won't get the condensation on the glass, but then you'll start to get damp issues or damp condensation build-up on the wall adjacent to the window, which can then lead to mold issues. The bottom left, you filled the cavity with insulation, so the wall is now nice and warm, as is your double glazing. However, invariably there's a cold breach because of the return from the block internally to the brick outside, which you can't insulate, and so you may still get build-up of condensation on those cold window reveals, and again potentially mold. The last little picture is a sort of the ideal situation where you have externally insulated your house, or it could be internally insulated your house, and you've had the windows fitted within that insulation layer in the same thermal envelope. So now it's all warm. There's nowhere for anything to condense. As long as you manage the ventilation, then you shouldn't get any problems with damp. So there we go. Replacement windows will be more airtight than your original ones. So condensation may build up in your house due to the reduced ventilation. This is essentially why the new building regs have introduced the idea of trickle vents being a mandatory thing, or at least ventilation being ventilation levels being very important. If you start to if you replace your windows and you start to see condensation building up around them, then like the little diagram above, what's happened there is you've warmed up that surface, and so it's now condensing on the one next to it, essentially. If you are getting these damp issues, then you need to manage your ventilation. Basically, you can do that by making sure that your kitchen has an extract, your bathrooms have extract, the bathroom door is shut, the kitchen door is shut. You know, these sorts of things really. And if you are getting new windows, then ideally get them with trickle vents. You can always close the trickle vents, but you might find that actually they're a very useful thing to have. It seems a bit counterproductive, really, when you put in brand new energy efficient windows, and then you're going to allow a lot of that energy out, got gaps in the top, but they're there for a very good reason. By the way, if you're finding you're getting condensation on the outside of the window, then that just shows that your window's really very good thermally. Choosing a supplier. I would suggest go local, because it's good to support the local economy, but also I think local firms are probably more likely to be concerned about their reputation locally. I would hope, and they're more likely therefore to produce supply quality product. Get recommendations from family and friends. Plus, Future Ready Homes has a list, I believe, a directory, which is a link of which is on the bottom there, and I'm sure they'll be happy to send that out. Always get 3 quotes. The Glass and Glazing Federation, GGF, is a members federation, and the members sign up to a consumer code. So if your supplier installer is part of the GGF, then you should get very good customer service, and you should, in the event of any issues, they offer a free reconciliation service, so they should help you through any issues. Official competent person schemes is very important. There's a number of them. I'm not sure whether that list is exhaustive, but there's certainly quite a lot. And you need them to be signed up to this scheme in order to prove that your windows are what they have to be. So you need them to prove that the building regulations certificate of compliance has been issued, that you have one. You need to comply with building regs. You need to need that certificate if you're going to sell your house to show that your new windows comply. You'll need that certificate if you to cover the warranty of the windows, should they come with one, and also for your own personal goods, so that you know that the windows do what they say they should do. I'm not sure how usual it is, but with buildings generally, it's quite normal to negotiate retention. So if you have £100,000 worth of building works being done, then it's normal to retain 5 or 10% for, say, a year, to make sure that anything that's defective or that's been missed will then be sorted out over that year before you release the final payment to the main contractor or the builder. And I don't see why you shouldn't also do that with your window supplier. Obviously, if you're only getting one window replaced, then it's such a low cost. They could just walk away and not be bothered to come back to fix something because they're only missing out on 50 quid or whatever. But generally speaking, I think if you're getting your whole house done, definitely try and negotiate a retention of, say, 10%, which you'll then pay after a year of use, when you know for sure that your windows are doing as they should be doing. Installation considerations. So energy performance is only because of the installation. There's no good having spent an awful lot of money on composite, triple glazed, gorgeous windows if there's great big holes around the frame and all the energy is just going around the sides. Windows should be factory glazed to avoid performance loss associated with site installation. Obviously, if you are having your glazing replaced in the existing frames, they might come and take away, say, a sash window. If you're having your sash windows refurbished, they may come and take the sashes away, which is probably the best thing. But they may not. They may just do it on site. So you just have to make sure they do a good job in that case. Gaps between the frame and the wall should be sealed with low expanding foam, backed up with a single-sided pre-folded high-performance adhesive tape, Proclean or similar, to provide an airtight bond between the window frame and the wall. This will be done on the inside. This also means that probably the plaster. Two ways of doing it. You could either knock off the plaster on the window reveals in order to take the windows to the masonry, to the brickwork, and then you can re-plaster over the top. You could, I suppose, tape onto the plaster, but again, you'd need to plaster or plasterboard over the top of that, so then you're losing some thickness, which might be an issue. Ensure that your low E glazing is installed the right way around, because you don't want to block heat coming in necessarily. You might do in the summer, but certainly not in the winter. And check the requirements for safety glazing, which again is anything below 800 mil on the ground floor, and then various other things depending on where your window is and what it's doing. Very quick note on conservatories. They're not thermally efficient. Even the very best quality glazing loses heat more quickly than uninsulated cavity wall. So it's recommended that you don't heat the conservatory. I must admit that we heat ours a little, just to sort of knock the edge off it, which is probably a terrible thing to do, but you know, otherwise it's just completely useless in 3 months of the year. Conservatories can reduce heat loss by acting as an extra insulating layer, a buffer zone, and they can also, during a nice sunny winter day, they can warm up in there, and then that heat you can then allow into your house, so they can work quite well in that respect. Double glazing blinds, shutters can all reduce the amount of heat wasted. It's not possible to bring a conservatory up to a thermal standard of an averagely insulated room, not unless you're going to re-roof it and essentially turn it into another normal room, which kind of goes against the whole point of the thing. And that is that. I've whizzed through that quite quickly. I hope that was useful for everybody.
Lovely. Thank you very much.